Hi, this is a quick introduction to Bash tutorial 6 that you'll have to do on your own. All right, so the first thing that I'll ask you to do is to back up your files just in case you do something that erases a file, some files of yours by mistake. Then we'll have a backup, and so if you do, then I can retrieve that for you. So the first thing I'm going to show you is something that you may enjoy actually doing and will be useful is to create a script that will assemble, link, and run a program for you. So I'm going to demonstrate that right now. Let's go to my handout directory, and I'm going to use the fib.asm program as a demonstration. So if I want to run this program, I have to assemble it. ld-ml i386 fib.o, the 231 library.o, I'll put in fib and then I run it fib. Okay, so that generates the Fibonacci terms. Now what I can do is to generate a script. So basically these three commands here I would like to be able to run automatically whatever the program is that I want to assemble, link, and run. So that works for fib, but I would like that set of commands to work for hello.asm and so on. So I'm going to create NALD, NA for NASM, LD for link. I will start with this line. You always need this line in a bash script. It's called the shebang. And everything that starts with a pound sign is a comment for bash. So it's going to look at that line as a comment, but the exclamation mark right after it will indicate to bash that the series of lines that follow this should be executed with this interpreter. And so what I want to do here is NA-NASM. Whenever I run this script, I want to NASM minus f, and I'm going to say $1. That's the first argument. I'm going to say the first argument that is given to this script, I want it to be given, and that first argument will have a .asm at the end. And then ld minus m alf i386 $1 first argument, but I want the name with a .o at the end with 231 lib.o, and the output will be just the name that I will run here $1. Okay, I'm going to save this. I'm going to make it executable, so that's something you have to do only once. chmod plus x NALD. So now NALD is a script and I can run it. NALD, please do your magic with fib, and that's it. It has assembled, linked, and run my program, and I see the output. Let's see, what other ASM program do I have? So let's do hello. So if I say NALD hello, NALD running here in my directory, then it prints hello there. So just that as assembled, linked, and ran my program hello. So it's a very neat little utility to have that will automatically assemble, link, and run whatever program you pass it on the command line. So the $1 will be replaced in this case by hello. Okay, so that's the first part that you're going to be playing with. And I'm also showing you that you could put this at the beginning of a Python program, and then Bash would execute it automatically. All right. So I'm explaining what the $1 is, and you have access to all the arguments that are passed on the command line. So I will ask you to create this little script and run it, and you're going to understand better how to access the arguments, how to count them, and so on. Challenge 1. Yeah, I'm going to ask you to create a script that contains that. So let's see what that does. If you remember first the nqueens program, if you say nqueens 8 minus q, it will give you a number of milliseconds, which is the amount of time that the nqueens program needed to find a solution for putting 8 queens on an 8x8 chessboard. And you can change that number. So if I say, how long would it take to put 10 queens on a 10x10 chessboard, it'll say 0.1 millisecond. And the minus Q makes it quiet so it doesn't display the chessboard as it's going around. So, for example, 10x10, if you don't put the minus Q, then you're going to see the program actually putting the different queens and trying to find a solution. So minus Q is nice because it doesn't display that, then you see the result. So if this was something that I wanted to somehow plot and I wanted to run this many times, I could say for n in sec 8 to 20 do Java and queens $n, which is the n that I have here, minus Q, done. And now I have the execution of n queens for all these different values. So I'm asking you to create a script to do that. That's the first challenge. Challenge 2, can you make your script, which will be called run nqueens.sh, can you make it accept the size, whatever you're going to pass to sec right here. So the idea here is that your sec will be $1, $2, basically, which is quite nice. Then I'm showing you how you can and how you should document your shell script. The shebang is always the first line, but then after that you can describe what the program is, who's written it, what it does, how to use it. Syntax is usually the keyword that you want to see. And then so here there's an assembly phase where I assemble my program, there's a link phase, and there's an execute phase, and you see that that script is very readable and therefore a nice tool to have, so I can modify it easily. Bash variables. So when we were doing that for loop, I here is a variable. So you don't need necessarily to have a for loop to create variables. You can create them very simply. For example, here is an example. And let's see how that works. Semester equals spring, course equals CSC 231, year equals 2019, and you can echo semester, that's spring, echo course. So whenever you use a variable, you need to put a $sign in front of it. When you create a variable, you don't. And echo year, you get that. And you can also echo semester, course, comma, year, and that will substitute the value of the variables in your output. It's something that is very nice. You can also run a command and the output of the command assigned to a variable. So for example, we saw before that if you look at the files in Etsy and count how many of them there are, you can do that. If I needed this for inside a script, for example, I could say number of files equals $sign parentheses ls Etsy word count minus L close parentheses. So now if I echo number of files, I will have 281. So I can store the result of evaluating a Linux command that can be complex, that can have pipes, and assign the result of that into, or save it into a variable. Challenge 3. I'm asking you to play with this file. So user share dict word is a file on Merax. It usually is on most Linux systems. And if you take a look at it, use less, for example, you're going to find that it contains a lot of words. So, and when I mean a lot, that's a lot. If you were to count how many, there's 99,000 lines, so 99,000 words in there. And that's often used on Linux system to generate random words for different things. So if I wanted to figure out what the 1,000th word is, I could do something like make it bigger. All right, so the 1,000th word in this file is Ashigaga. If I wanted to know what the 10,000th one is, that's Mercs. Anyway, so using that, try to figure out a way of generating random words, knowing that there's a specific variable in bash, which is called random, and when you call it, it gives you a random integer. Okay. The maximum number that it can return is 32,000, but that's probably good enough for us to generate random words. Okay. So if you get the date, just by itself, you get the standard date, which is this whole expression. But you can change the format by asking for the date in a different format with a special string here that says, please give me the date, but give me the year, the 4-digit year with a dash, followed by the 2 digits for the month with a dash, followed by the 2 digits for the day. And if I do that, you see that it formats that very nicely. If I store that in a variable, for example, my date equals $open, close, so now echo my date, then I'll have that. So if I want to tag a file with this, then I could do, for example, copy dummy.txt, which is a dummy file, to my date dummy.txt. So now as minus LTR tel minus N5, you see that I have my dummy file, dummy.txt, and I also have now a version of it, the copy of it, that has the date tag to it. So why did I use curly brackets here? If I didn't, then bash wouldn't have been able to understand the commands. If I remove it here, then somehow I'm asking bash to use a variable that is called myDateDummy, and it would not know how to create it or to read it. So if I want to somehow separate my variable from a string, which is what I have here, then I put curly brackets around it. So now bash will be able to recognize the name of my variable inside this whole string. All right, and then I'm going to show you how to do arithmetic expression, how to add and subtract and multiply things in bash. So the expression or the command to do that is called expr, and you'll just play with that, and just remember that percent is modulo, multiply is backslash star, and you'll have a nice little challenge here, which will have you create a teller machine program where you give it a number of dollar bills and it tells you how many 20, how many 10s, how many 5s, and how many 1s you need. The bank will give you back. $100 would be 5 20s, $37 would be 120, 110, 15, and 2 1s, and 0 corresponds to all zeros. Hope you enjoy this. Good luck.